right, we're going to jump into our very last lesson of chapter 9, which is super exciting. We are going to be focusing only on slope-intercept method. I do want to remind you, if you get to a problem and you feel stumped, try a different method. I think that XY chart is probably the most familiar because it's the one we learned all together. Use that to help you out. Try some problems from that and then go from there, okay? Or try a problem using that and see if it matches what you think you should be getting. So, with that in mind, let's jump into example number 1, graph using the slope-intercept method. So again, we first want to make sure that y is by itself, and it is. Y is on a side by itself, correct? Now we're going to identify the slope and the y-intercept. The slope is the number that is what? Is it being multiplied to x or a constant? The slope is the number being multiplied to x, so we have negative 5/2. Doesn't matter where the negative goes, out front, on the 5, on the 2. No, it can be either place, right? Just one of them, though. The y-intercept is 2, right? And as a point, so our y-intercept, we know that the x value is always going to be 0, and our y value here is 2. So from there, we go over to start graphing. The first thing we graph is what? Make sure you guys are getting ahead of me here. The more you do on your own, the more you'll understand and remember. So the first thing you should be doing is that graphing that y-intercept, 0, 2. So 0 on the x, 2 up on the y. Make sure you're graphing that y-intercept as a y-intercept, not an x-intercept. It's 0 on the x, 2 on the y. Now from there, we use our slope. First of all, I notice that is already in fraction form. Okay. Now you can treat this as negative 5/2, or you can treat it as 5/-2. Okay, it needs to go on one of the numbers there. So we can use both of them. We'll talk about that as we go. I'm going to start with negative 5/2. Now, if it helps you to write it over to the side and label it rise over run and think about if that's going to be up or down. So we have rise and we have run. Now remember that rise means up and down, right? And run means back and forth, left and right. Now, looking at these numbers that were given here, negative 5, would that be up or would that be down? Negative 5 would be down, right? And run, since this is a positive 2, would it be to the left or to the right? And it's going to be to the right. So we're going to go down negative 5 to the right 2. All right, so let's do it. From our y-intercept, we're going to go down 5. So 1, 2, 3, 4, 5. And we're going to go, according to our work over here, to the right 2. Down 5 to the right 2. Now we can't go again in this direction. Let's see if we can fit it at the top of the graph. So again, instead of going down 5, right 2, could we go up 5, back 2? Let's try it. 1, 2, 3, 4, 5, back 2. When we do that, we're changing the sign to the negative, or to the 2, making that negative, and we're going to go up 5, back 2, or down 5, over 2. And we've formed our line. So go ahead and use your straight edge and draw that line in. Ooh, and I kind of missed my points a little bit, but it'll work. All right, there it is. Moving to example 2 now. Moving to example 2, again, we're going to use slope-intercept method. Ooh, this one looks very different, but let's jump into it and see what we can figure out. Now, before we talk about this, and we'll kind of use slope-intercept method, but it might be helpful to think about it another way. And let's actually change it. We could graph it this way, but I think it'll be easier for us to think about graph using the XY intercepts. Okay, so let's change it. So to find an x-intercept, you could do it the other way, but I think this will make more sense to us. To graph an to find an x-intercept, we plug what in? We plug 0 in for y, right? To find a y-intercept, we plug 0 in for x. So let's do it. If we're finding the x-intercept, if you plug 0 in for y, now is there a place to plug 0 in for y? No. So if you plug 0 in, x is negative 2. Could you plug any number in and x will always be negative 2 here? Yes. Okay, so that might give us a hint. Now, here we have 0 in for x. So now there's actually a spot to plug it in, so we're going to plug 0 in there. 0 equals negative 2. Is that a true statement? No, right? That's false. We can't do any solving, and it is false, so we're going to say no. Okay. So that means that there's actually not a y-intercept. So let's graph that x-intercept, negative 2, 0. So negative 2, 0. Now, it doesn't have a y-intercept. What kind of point would it have to be to go through this point right here? What kind of line would it have to be to go through this point but never touch the y-axis? Because it says it has no y-intercept. What kind of line would hit the x-axis here at negative 2 but never go through the y-axis? It would have to be what? It would have to be a vertical line. Okay, this is x equals negative 2. And anytime you have a line that is x equals some number, it is a vertical line going through that point on the x-axis. So for example, if you had x equals 4, that would be a vertical line going through 4 on the x-axis. Okay, coming down to example 3. Again, we're going to use slope-intercept method here. Now, this looks more like a problem we did when we were doing x-y intercepts, but we're going to use slope-intercept. What is the issue here? All of our problems before have had what? All of our problems before have had the y by itself, but it is not by itself here. So we are going to have to use some solving techniques to get it by itself. So looking at y, remember, we do order of operations backwards when we're solving. We're trying to get y all by itself. So we have addition here, right? These are being added together. We also see multiplication between the 5 and the y. When we are solving, remember, we use order of operations backwards. So the first thing we're going to do to get 5y by itself, and eventually we're going to get y all by itself, is to subtract 2x from both sides. Okay, so just hang with me here. I'll explain what we're doing. 2x minus 2x goes to 0, right? And this is a positive 5y, so we'll just copy that down. Now, can you combine 10 minus 2x? Are those like terms? Do you need like terms for subtraction? And we would say, yes, you do. So we are going to write these. Now, we could do 10 minus 2x. That would be fine. But since we like it in our specific order that we usually have for slope-intercept form, we're going to switch these around. Now, be careful. Remember, this is negative 2x, and this is positive 10. So it's going to be 5y equals negative 2x plus 10. Okay, plus 10. Now, we are going to divide both sides by 5. This is something a little bit different than what we've seen before, so I want you to stick with me here. 5y divided by 5 is y, which is exactly what we wanted to happen. Now, when we have this 5 here, you cannot just divide 10 by 5, and again, we haven't learned this before. I'm teaching you right now. You have to divide each term by this denominator. So you need to take, remember, terms are separated by plus or minus signs. So here's where it's separated. So you're going to divide this by 5, and you're going to divide this by 5. Okay? So we have negative 2x over 5, and then we have 10 over 5. So we're going to divide each term by 5. So let's simplify this just a little bit. So we have negative 2/5 x, which looks more familiar to us. And then we have 10 divided by 5. They're both positive, so it will be plus what? 2. And now y is by itself, and we are ready to graph it. Okay, so let's go ahead and go and do our usual steps. So y is by itself. Our slope for this problem is what? Negative 2/5. And our y-intercept is what? 2. And if you want to write that in point form, you would say 0, 2, right? Okay, so the first thing we do is plot our y-intercept, 0, 2. And then we're going to implement our slope. Remember, you can put the negative on the numerator or denominator. I'm going to leave it on the numerator for right now. So that means, that's the rise. So that means we're going to go down 2, and the denominator is the run. Since it's positive, we're going to go to the right. So we're going to go down 2 and then over 5. So down 2 and then 1, 2, 3, 4, 5. we can also do it in the opposite direction, right? Up 2, back 5. Oh, my eyes are tripping out right now. Okay, 5. And we have our line. Does this match? Does this have a negative slope? Does this have a y-intercept of 2? Yes and yes. So let's draw that straight line in there, and let's move on to our final example for the day. All right, last one. Example 4. We're going to use slope-intercept method, and again, we notice that y is not by itself, so that's what we've got to do first. Our first step in getting y by itself using order of operations in reverse is what? Go ahead and write down what you think we should do first here. And that should be to subtract x from both sides. So x minus x goes to 0, which is what we wanted to happen. We have negative 3y equals. Now, 9 minus x, are those like terms? No, this is very similar to the problem we just did. 9 minus x, they are not like terms, so you can write 9 minus x like this. Remember, for slope-intercept form, we usually have the x term first and bring the sign with it. Remember, this is a negative x, so bring it with it. Negative x, this is a positive 9. That sign is in front of it, not behind it, equals negative 3y. All right, last step to get y by itself. How do you get y by itself here? Divide both sides by negative 3. And you learned that we have to divide, up here you learned you have to divide each term by that number, okay? So we'll do that ahead of time this time. So we'll divide this. This is the first term here. This is the second term. We're going to divide them both by negative 3. So negative 3 divided by negative 3 is 1y. 1 times y is just y. Now we have a negative. Now if you don't see a number in front of this x, what should it be? It's a 1, right? So first of all, a negative divided by a negative is a positive, and we can leave this in fraction form 1/3, and we can write the x inside of it. We can also write it next to it, and that's the way we've been seeing it. So that's the way I'm going to write it here. Then we have a positive 9 divided by a negative 3, so that's going to be minus 3, and we're ready to graph. So let's wrap this up. Slope is 1/3, and y-intercept. We know that the x value is 0 and the y value is negative 3. So let's graph it. So we're graphing 0, negative 3, graphing that y-intercept first, and then we're going to our slope. These are both positive, so they're either going to be up or right. Remember, rise is in the numerator, run is in the denominator, and rise means up if it's positive, and run means right if it's positive. So we're going to go up 1 to the right 3, up 1 to the right 3. We can also do the same thing but in reverse. So down 1, back 3. We can see that they're all falling in line, as they are all part of the same line. Once we have at least 3 points, I'm going to grab my straight edge and draw that line in there. Arrows on both ends. And I'm finished. That is lesson 2 of our week.